this up here, just talk about your restricted domains for a minute. Your sine curve. Your sine curve looks like this. Sine. Here's your sine curve. Now, we said everything uses quadrant 1. Quadrant 1. So, we break it right here before we turn. We come back down, we break it right here. We're in negative pi over 2 to pi over 2. This is your restricted domain. On your circle, what quadrants do I find pi over 2, 0 to pi over 2? First, what quadrant do I find 0 to negative 90, negative pi over 2? 4. So, when you do this, you are restricted to 4 and 1. Notice the 1 has the sign positive. The 4 has the sign negative. We did this yesterday. Even if you can't find it yourself, then memorize it. If you can't understand where it's coming from, memorize it. The sine and the tangent basically have the same one, 1 and 4. Hang on 1 second. The cosine has 1 and 2. Really, that's not a lot to think about. If you do your homework and you don't look up your notes from the day before, yeah, you don't remember anything. Go to the Moodle, look at the class again, go through the classwork. If you didn't do it with me, you probably don't have anything in front of you to use. I'm not taking that as an excuse. You're in a pre-calc college level class. That is not an excuse. I did not know what to do. No, I'm really not feeling that in this class. It's time you start stepping up to the plate in this class. And I'm not kidding. So now, let's do your tangent curve. Your tangent is the same thing. Here's your tangent. Your tangent is even nicer. Because we said it has a natural boundary right here. There's your piece of tangent curve right there. So your domain is going from negative pi over 2 to pi over 2. Same as your sine. The only difference is we can't use the negative 90, the positive 90. When you go to make your unit circle, you're doing this piece right here. You're doing from 0, 1, 1, 0 to 0, negative 1. All of this for your sine. For your tangent, you're doing the same piece, except you just can't use this one and this one. So quadrant 1, the tangent is positive. Everybody's positive in quadrant 1. Quadrant 4, the tangent is negative. That really should not be too difficult. And the only one that's different is your cosine curve. Cosine is the different one. The cosine looks like it's different too because it starts up here. And it goes like this. Now, cosine can't come backwards because it'll fail the horizontal line test. So as we go forward past the 90 to the 180, so from 0 to 180 is your restricted domain. Look at this. Here's its positive. Here it dips below. There it's negative. So you've got quadrant 1, quadrant 2. From here, it uses this, and it uses this. Positive, negative. From 0 to pi. That's your domain. Now, how difficult was that? 3 restricted domains. Okay. Let's take a look at your work now. Okay, I need to find an angle, a restricted angle, arcsine, sine negative 1, restricted domains. So where is my sine restricted to what quadrants? 1 and 4. So if I want the positive, what quadrant does it have to be in? 1. Drop your special triangle. You better know this angle by now. There's your 30. 30 or pi over 6. Your restricted domain went from negative 90 to positive 90. Arc sine of 0, it's got to be somewhere between here and here. You know your 1s and 0s for your sines and your cosines are on your quadrants. So is sine the y value or the x value? The y. So I look at my y's and I see out of all of these, which one is 0? This one? This one? So what degree is that right there? 0. Either 0 degrees or 0 radians, whichever one you choose to write that one. And check it in your calculator. Second sine 0. Remember, your calculator gives you the restricted angle. So it's got to give you the right one. I said yesterday you could kind of even cheat on this because you can put it in your calculator and then locate it on your graph. You can do that. All right. Arc sine is restricted to 1 and 4. Again, you're looking for your y value. There it is at the 90. Cosine, you're looking in 1 and 2 here, including the quadrants. Cosine is the x or the y? The x. So where's cosine 1? Right here, at the 0. Try it. Second cosine, 1. What do you get? Angle of 0. What, Chris?
I said, did you show us how to do that yesterday?
Yes, we did that yesterday.
We didn't do this one.
We didn't do the quadrant angles yesterday? No? But you know all your quadrants are 1s and 0s. You even have your chart that you made with your 1s and 0s. Okay, tangent. Tangent is restricted to what quadrants? 1 and 4. Which one is positive, 1 or 4? 1. So I'm in quadrant 1. Remember, we've been doing these, guys. We said sometimes it's better to, like, unrationalize it. It makes more sense. So if I unrationalize it, it looks like this. There's my special triangle. If not, figure out your side. If you didn't do that, if this is my y and this is my r, God bless you, you can figure this out. You can put this in, in Pythagorean theorem, you can figure this guy out. It's a little harder to spot. Or you could cheat even. Second tan and put this in. Find out what angle you are. And set it up for that angle. Your calculator does your restricted angles. Arctan -1. Those you should know now. The tangent of a -1, what angle is that? The tangent of 1 even. What angle has 45? So where am I? Quadrant 4 if it's negative. Remember, this guy goes, even though this has a 45-degree reference angle, you have to give this to me from negative 90 to positive 90. You can't give me 315. That is not in your domain. So negative 45 is in your domain, isn't it? I have to be honest, you did this last year. There's nothing new that we did this year. Nothing new. We restricted your domains the same way last year. And maybe your teacher had you memorize it instead of do it with the graphs. But it's so much easier to look at the graph and restrict your domain. Arctan, where's tangent negative? Quadrant 4. There's your special triangle. It has a 60-degree angle. I have to go from negative 90 to positive 90. So my answer is negative 60, negative pi over 3. This is the exact same thing, isn't it? Exact same triangle in a different location. Instead of 3, I'm in 1. Okay?
You could leave the answer in degrees.
Oh, you can, well, I didn't specify, so if you gave it to me in degrees, that's fine. Normally it'll say, like answer in radians or answer in degrees. The reason like degrees are easier, when you go to your calculator and you do second sine, second cosine, it's easier to pick up that angle in degrees than it is radians, because the radian measure, you'll get whatever pi is divided by 3, divided by 4. You'll get all that in your calc. It's harder to see it. Questions?
Sorry, that's a quick question. So basically just put on your calculator and you have to figure out where to
No.
put it.
Basically, don't put it in your calc. Basically, see where your sine and your cosine, your tangent are restricted to what quadrants. And set up either your quadrant angle or your triangle. By putting it in your calculator, it kind of gives you, like, if you really have no clue where it's going, when you put it in your calculator, it will show you where your angle is. Then you can cheat and work yourself backwards if you have to. But I want you to understand where we restrict your sine curve and why. It can't fail a horizontal line test. So the minute it goes over that hump there, we have to cut it off. So that's why sine goes 1 and 4. Cosine goes 1 and 2 because it starts at the top. So it comes down to 1 and 2. Sine and tangent are the same. Cosine is 1 and 2. So that's the only ones you get. If you notice when you put it in your calculator, like yesterday, we said the sine of -1/2. I should find 2 angles that have the sine -1/2. I only get 1 in my calculator because it only does the restricted domain, not any angle. Okay, so same thing. Sine -1 is your inverse sine, just like your arc sine. So where is sine positive? 1. Label your triangle, find your angle. This guy, again, you kind of saw that before. You can unrationalize that, make it easier. Remember to give me the negative angle. I think that's the hardest part. When you go into quadrant 4, you need the negative angle. It's not the positive that you go all around with, because it's restricted. Number 17 and 18, we're basically asking you the same thing. I like this, but it was basically just asking, it gave the inverse graph, and it said, like for this one, if I'm looking at the tangent curve, what's the tangent in quadrant 1 for an angle that's 45 degrees? What is the tangent of 45? 1. So there was your answer, 1. It looks a little bit more
So what
confusing.
all that work?
Well, because sometimes it asks for the angle, so I put the angles. I just showed you what each one came out and did. You really didn't have to even go that far. If you came down here, you're in quadrant 3 here. So what angle is this? You're in quadrant 3. Let me see what angle this is. What is this asking for? If you're negative pi over 6, this guy right here, you're here in quadrant 4. You're negative pi over 6 in quadrant 4. It wants to know what is the value of that angle's tangent, because you're in the tangent curve. So you drop your triangle. This is a 30 degree. 1, radical 3, 2. You find your tangent. Tangent is -1 over 2. And that's what you put in here. Oops, tangent, sorry. Tangent is -1 over radical 3. And that's what you put right in here. -1 over radical 3. This guy asked it a little differently. It said if my tangent is negative, so I'm in quadrant 3, my tangent is y over x, what is my angle? So we drop our triangle, that's a 60 degree angle, so therefore -60 or negative pi over 3. It just gave you the inverse part of it and said, either I'm going to give you an angle, tell me what the tangent is, or I'm going to give you a tangent, tell me what the angle is. The angle can only go between 1 and 4, because that's a restricted tangent curve. Your cosine is restricted to 1 and 2. So anything positive is in quadrant 1, anything negative is in quadrant 2. So what's the value for cosine if I'm a 30 degree angle? So we drop a 30 degree angle and we figure out your value of cosine. It just kind of put it on your inverse curve. Do I expect you to graph it? No, I can't graph it. I can't graph the curves either. I don't expect you to graph it. I do expect you to know the domain restrictions. Yes. No, but it's a nice thinking question. I didn't make a test yet. But when you do this, it's a nice thinking question. What is this asking me? It's giving me my x and then my angle. So obviously we reversed this. We took the inverse of this. So find me the cosine for this angle. If I give you a cosine, find me the angle. If my cosine is -1, I'm here, over here. So I'm at pi. There's my angle, pi. If I'm at -1/2, I'm in quadrant 2, x over r. I got a 60-degree angle. 60 degrees now in quadrant 2 is 120 degrees, which is 2 pi over 3. Your restricted domain for cosine goes from 0 to 180. Yes?
Yep.
So we locate this parentheses. What is that asking us to do? Inverse. Find an angle. Right? Inverse. We're doing our true inverse. An angle, a restricted angle, whose tangent is -5. Where we just have to locate where this is first. Now, arctan, what does arctan tell us? Inverse. We're doing our true inverse. So our true inverse for arctan says what quadrants?
1 and 4.
1 and 4. Out of 1 and 4, which one is negative? 4. So far, this puts me in quadrant 4. My tangent is y over x.
We have a question here.
Go ahead.
So sine is 1 and 2.
Sine is 1 and 4.
Oh, so they're all 1 and 4?
No. Cosine is 1 and 2.
So sine and tangent are 1 and 4.
Yes. You got it. That's all it takes.
Oh, and tan's the one that can't cut the negatives on the top and bottom.
Yes. It can't do the quadrant angles. Because there is no tangent for 90 and 270. A -90 in this case. Now, we've located this. Normally, if that's all it says, if I cover the word tan, I have to locate that angle. That's not my special triangle. But it needs something else. So I've located it. Now I come outside my parentheses and it says, take the tangent of this angle. Whatever this angle happens to be, take the tangent of this. Now, your tangent is y over x. So therefore, my tangent is -5. Okay, think this problem out. Now, why did that work out that way? Why did it work out that way?
Oh, that's the answer. Wait, where'd you get
Donovan, why did it work out like that? You took the inverse. It said this, guys, watch. It said, take the tangent. Listen to what it said. It said, take the tangent of an angle whose tangent is -5. So what is it asking you to do? The tangent is -5. What if I said this? What if I said this? I got to take the sine of that angle. So Aaron, how do I find the sine of this angle? Yeah, I've got to find the hypotenuse first. I got to find the radius. So I'll do 1 squared, guys, plus 5 squared. So I got 26. I got to take the square root. And can we reduce radical 26 at all?
I hope so.
No. Nope. So how do I find the sine now of this? I say y over r. -5 over radical 26. It said, locate this angle for me, whose tangent is -5. Now it just said take the tangent of it, but now I changed it, said take the sine of that angle. So we located it first because it's in your parentheses, and then it's kind of like one of those like Yeah, well, if I changed it to sine.
So we didn't have to draw a graph.
You do have to draw a graph. And in that case, no, because it was asking you to take the tangent of a restricted angle whose tangent is -5. So that one, I did that for a reason so you could see what it's looking for. It helps?
We don't have to leave.
Well, we'll look at your next one.
Uh-oh.
The original problem is -5. Then I said take the sine of that angle. Okay? Now, next one says a little bit differently. What am I looking for? I'm looking for the sine of 5 pi over 3. So let's find this. Where do I locate 5 pi over 3?
First quadrant.
Well, if this is 3 pi over 3, and this is 6 pi over 3, where am I? Fourth quadrant. Everybody okay with that? What's my reference angle? 60. 3 goes into 180 how many times? 60. Right, so far? Now I can label my triangle. And what is the sine of this angle? Sine is y over r. So negative radical 3 over 2. So now I'm going to say arc sine of negative radical 3 over 2. I'm replacing this with what we found. We found your sine of 5 pi over 3. Was 5 pi over 3 a restricted angle? No. So we plotted it. We found it. Now, my statement says, I resolve this. It says arc sine of this. It says find me your restricted angle. This says restricted angle of negative 3 pi over 2. It just so happens sine is located in 1 and 4, and the negative is located in 4. So far I'm in the right spot. But what would my restricted angle be? Negative 60. Very good. Negative 60 or negative pi over 3. Now, why is that? Because what, Dan? No, go ahead. Go ahead.
Because it can't go past the angle.
It can't go past here. We got to go from here to here. We're from negative 90 to positive 90 on a restricted angle, right? We're restricted this time. Remember, whenever you see the word arc something, like arc sine or sine -1, this means restricted. I need to find the restricted angle. So inside the parentheses first says resolve this. Tell me what the sine is. Now it says give me your restricted angle that has this sine. My restriction says from negative 90 to positive 90. If it helps, make a number line like this. Negative 90 to positive 90. This is where your axis goes, isn't it? This is where your restricted curve goes, right in here. So what happens is I can't put 120 out here. I can't put 5 pi over 3. I can't put 6 pi over 3. I can't put 2 pi over 3. I can't put anything. I got to be in here. So I can't use 5 pi over 3. It's out of my domain, my restricted domain. So I realized, oh yeah, it's the negative. Okay? So even though it led us to the right area, we just had to kind of name it a little bit different. We just named it a little bit different. Now, this one, I don't want this one to confuse you. I'm not crazy about this one.
Which one?
Number 3.
Number 1 since homework is on from 1 to
What do you mean?
the brackets.
Number 1?
Which is a harder one than homework.
All right, we'll do number 1. If the bracket is the same as your bracket,
Oh,
it's the same as a soft bracket. So let's find this first. What is this looking for? A regular angle or a restricted angle? a restricted angle. So, cosine is restricted to what quadrants, Jada?
Wait, what?
Cosine is restricted to what quadrants?
1 and 2.
1 and 2. And out of 1 and 2, which one is positive?
1.
1. So my triangle exists in quadrant 1. So x over r. Now, I don't want the angle, but I now want the tangent of this guy. So tangent says opposite over adjacent, y over x, but I need to do Pythagorean theorem to find it. So b is equal to radical 5. So now how do I find the tangent? Y over x, radical 5 over 2. There's my answer. It's not that bad. We're inside the parentheses first. If it's got an arc or a sine -1, then you're restricted to wherever you're supposed to be. If you're not restricted, it lands anywhere that it lands up.
Okay, would you rather answer y over x equals?
Well, I usually just write radical 5 over 2. I do y over x so you know how to find your tangent.
Okay.
Yeah. Okay. So, that's your homework. We have time for one more.